Now, sixth person also joined. So tell me, all of you, are you clear so far? Particularly the last class, RK also, Dr. RK also taken some sessions. Please tell me, have you understood everything clearly? I think we have discussed about measure phase. Am I right?
Yes.
Yeah. So what did we learn there? And what is your understanding right now about measure phase? Come on, all of you speak along with me because my throat is also not that much supportive. If you keep quiet unnecessarily, I'll be talking too much and it will invite in, get take me to some other issues. So be interactive. So what did we learn in the measure phase? Now I want to discuss with you about the analyze phase. In measure phase also, and in analyze phase also, we learned the basics in yellow belt. Now we need to really understand the statistical tools. So before that, please confirm me. Are you good with the measure phase? You know what is measurement system validation?
Yes, sir. Last week
Yes.
we learned about CP and CPK and how to calculate that.
CP and CPK, we are speaking about baseline performance.
Hmm.
And before measuring baseline, before collecting data, you must first validate your measurement system. Whether my measurement system is good or not, that I should know.
Yes,
For
Yes,
that,
sir.
I do a pilot data collection and see how much variation is there in my data, which is, an experimented data collection. It's not a real data collection. We do a pilot data collection and then based on the data collected, we try to understand how much is the measurement variation. Measurement variation is nothing but the measurement error, isn't it? There are two types of error, repeatability error, and another one is
Reproducibility.
reproducibility error. And both put together is known as precision error. This precision error, how much it is in comparison to the tolerance provided by the customer. Customer has given me a tolerance. My measurement system has got this much variation or this much error. So we call it precision error. This precision compared against customer provided tolerance is known as precision tolerance ratio, which is otherwise called as gauge R&R value, which is otherwise called as gauge R&R value. This gauge R&R value should be lesser than 10%. Isn't it? This gauge R&R value should be lesser than 10%. If it is more than 10%, let's say 10 to 30, conditionally acceptable. More than 30%, measurement system is unacceptable. All of you are aware this much?
Yes, sir.
Yes, sir.
So once you are sure gauge R&R is lesser than 10%, that means your readings are consistent. Your readings are consistent. Now you actually collect data or now after with the collected data, you see how close your data points are with respect to the true value. If your data points or if the measured value is away from the true value, we give it a name. The distance by which the measured value is away from the true value is known as bias. Am I right? So by all means, the measurement error has to be lesser than 10%. Not only gauge R&R. After gauge R&R, bias comes into play. Do you understand what I'm speaking? There can be error due to gauge R&R. Over and above, again there is possibility for bias. So imagine you have a wristwatch, you wear a wristwatch, and right now the time is 7:14. Imagine your wristwatch is showing 7:25. Instead of 7:15, it is showing 7:25. That means there is a bias, isn't it? Bias of 10 minutes. And this bias can be positive or negative. So ultimately, after correcting for the consistency, that is gauge R&R, now you should correct for the bias also, existing bias. We already spoke in the yellow belt. If the bias is constant, you can call it, you can calibrate your data or you can calibrate your measuring instrument, or you can plan the calibration frequency of the measuring instrument. With all of this, the measurement error can be brought below 10%, right? So there are two things I'm talking here: inconsistency. Another one is inaccuracy. Inconsistency is known as gauge R&R. The inaccuracy is known as bias. So now the measurement system is acceptable. We collect data and we go for the baseline. And when we go for the baseline, there are different tools: DPMO, defects per million opportunity. And there is a tool known as yield, traditional yield and first pass yield and rolled throughput yield. And there is one more tool known as CP and CPK. All of these were discussed with you. Am I correct? Now when will you use DPMO or when will you use CP/CPK? Any idea? Come on, I want all of you to be active. And these modules, don't expect like your the yellow belt level discussion. This has to be fully discussion mode. I think this was already taught. I'm only trying to recollect. You should be able to speak along with me. So CP/CPK. Yes.
So when the customer has provided us the lower specification limit and upper specification limit, okay, it means in that range, if we know our data is in that range and we have to identify the defect, so then in that case we should use the CP/CPK.
Okay. But one important point you missed out is if the data type is continuous.
Correct. Yes, sir.
If the data type is continuous, then only we go for CP and CPK. If data type is discrete or attribute data, we just go for DPMO or yield directly. Now, in order to calculate CP and CPK, you should know the upper spec and lower spec, which is normally provided by the customer, right? And process average and process standard deviation, you should know. Process average and process standard deviation. Why? Then only you understand whether your process is fitting perfectly inside the spec or not. Imagine the customer provided tolerance as the parking area. Imagine a parking area. Yeah, there is a place available for parking your car. Now, this is the tolerance given by the customer. Now, it's very important that your car is smaller than the parking area. Am I right? If your car is not smaller than the parking area, your car cannot go inside. If the car cannot go inside and you still try to take it, definitely there will be damage. Same manner, customer has given you the tolerance. Your complete process has to go within the tolerance. Suppose for some reason, if you have designed your process badly, if the size of your process is bigger than the tolerance provided by the customer, by nature of the process, by nature itself, your process will produce rejection, which you cannot avoid. All of you are with me? After buying a big car, if you ask me, sir, why the car is not going? Because you purchased the wrong one. Just because you can't change, area because construction is over. Similarly, customer has fixed the tolerance and you designed the process badly. Now you must live with rejection. So the only way you can get rid of it is improve the process. When I improve the process, means my car size will keep on reducing. All of you are able to understand what I'm speaking. The car size is equal to the spread of the process. Car size is equal to the spread of the process. You see here, let me write something. Now all of you can see my whiteboard. All right, all of you can see my whiteboard.
Yes,
I've
sir.
drawn two lines. Now this is lower specification limit and this is upper specification limit. Now I can have a process like this. Can you see my process? Process is centered here. The center of the process represents process average. And my process goes up to this point on the right side, up to this point on the left side. This point is known as upper control limit. This point is known as lower control limit. Can anyone here, can you tell me what will be the distance between upper control limit and lower control limit?
3 sigma, right? No, sorry, 6 sigma.
Very good. I want everybody to tell this 6 sigma. In any process, the spread will be equal to 6 times sigma. Where what is sigma? Standard deviation calculated from the process data. Standard deviation calculated from the process data. For the same scenario, yeah, I can also have a process like this. Can you see a red color process? Can you see red color process? That is all. Oh, sorry. So that is also so that is also centered at the same place. So center-wise, there is no problem. But where is the problem? The problem is with the spread. Am I right? If I say this as sigma 2 and this as sigma 1, the problem is sigma 2 is more than sigma 1. The red color process is prone to produce a lot of defective items simply because it is bigger than the size of the parking. Size is the provided by the customer. One minute. Okay. So now please understand, in order to understand whether my process is capable or not, I always check my process with respect to the specification limit, upper spec, lower spec. In case if my process is perfectly fitting. Now please note, my upper control limit is exactly touching upper specification limit. My lower control limit is exactly touching lower control limit. Now I want to go for a formula, which is distance between the specification USL minus LSL divided by UCL minus LCL. UCL minus LCL. So USL minus LSL. What is UCL minus LCL? 6 sigma. Now this is giving me CP value. This is giving me CP value. If the process specification or that if the customer provided tolerance and the spread of the process are equal, CP will be equal to 1. Am I right? Come on, yeah, if you are not saying, keep saying yes and no. I have no clue whether you people are, understanding my language or not. And this is not a common English language, which, you can easily understand. You are hearing CPCPK here only, isn't it?
Yes, sir. Sir, just to clarify, CP is equal to USL minus LSL by 6 sigma, right? And what is
Yes, correct.
UCL? So what? I just didn't understand the UCL part. No, sir. In the second diagram, it's a second equation.
Here, right? 6 sigma.
Sir, on top. Oh yeah, on top there's UCL, right? What is that?
This one you are saying?
Yes, sir. Yes, sir.
See, that
Oh.
I have marked for this.
Oh, okay. Never mind.
That's all the formula. So the formula for CP is USL minus LSL divided by 6 sigma. That's all.
Got
So
it.
in order to calculate CP, all that you need is sigma.
Sir.
And USL customer gives, LSL customer gives. But problem here is when CP equal to 1, what do you understand is your process just made it. Am I right?
Hmm.
So I stopped the sharing. So CP equal to 1 means your parking area and your car size are equal in size. Or equal in size. If they are equal, just capable. Now, let me tell you another scenario where your car is half the size of the parking area. Your car is half the size of the parking area. Now your car can go comfortably into the parking area. Yes or no? Even if you make minor mistake, your car is slightly shifting to left or right, still you will be able to park it safely. You will be able to park it safely. So having some extra, not consuming all the tolerance given by the customer is always a good idea. So that is what we are checking with the CP. That is what we are checking with CP. But now tell me, if your car size is smaller, does it mean, it is definitely advantageous. Does it mean accidents can never happen? Tell me, if your car size is smaller, does it mean your car will never get into any accidents while parking the car?
No, sir. There's always a chance of an
Always a
accident.
chance. Tell me how things can go wrong. You have got a very small car, but still how things can go wrong if you
Sir,
drive the car badly.
so yeah, if you drive the car badly, if you don't park
Yeah.
properly.
If you have the tendency to shift towards the left or shift towards the right, you end up damaging your car. So whether that shift is happening or not, you can understand only if you look at X bar. Only if you look at the X bar. Now tell me. All of this, let me know. Now imagine you have a parking area and I am going to show you the position of a car. You just have to tell me whether there is a tendency for shifting towards left or right. That you all have to tell me, right? So I have the upper spec, lower spec, and now my car is here. Now tell me, is this driving proper or is there any tendency to shift to the right or left? Looks to be. Now another
Looks
scenario,
perfect.
where my car is here. Now the first scenario is here, second scenario is here. What is the difference between first scenario and second scenario? Tell me. First scenario, the process average is x1 bar. Second scenario, the process average is x2 bar. First scenario, the x1 bar is right on the target. Am I right? Come on,
Yes.
yeah.
Yes.
Yes,
It is
yes,
on the target.
yes, yes.
But the x2 bar is shifted to the right of the target. That means its value is more than the targeted value. Please note.
Right.
But if you look at our formula, which just now we understood for CP, what is our formula? CP, can somebody tell me USL?
USL minus LSL divided by 6 sigma, 6 times of standard deviation.
Oh, if you look at this formula, it only makes use of X sigma. It doesn't use X bar, isn't it? There is no X bar in the formula. Can you see here, all of you? There is no X bar. That means the formula has got a limitation. It cannot detect whether the process is shifted to the right or left. Only with the diagram you can tell, but not by using the formula. Can you see that, all of you? If the process is shifted to the right or shifted to the left, formula wise CP is same. Value will not change. So CP is not a good measure of capability. That's what I want all of you to understand. CP is not a good measure of capability. So we introduced one more metric, which is known as CPK. Do you remember? This was discussed or not with you the other day? CPK. Now, trying to understand CPK. So let me remove all of this. Let me now take you to slides. I think that would be helpful. Okay. So let me now share my PPT. Wow, module 2. Please confirm. Can you see my slides?
Yes, sir.
Yeah. So this is the formula. You can see CP formula. And this is the formula for CPK. Right? And see here, the advantage is, can you see X bar in your formula? You can see X bar here. Here there is no X bar. And now look at the slide and tell me, is this process capable? Is it capable or not? And now it is shifted. Since it is shifted, you can see some rejections happening in this region. You can see rejections happening because this portion of the curve is going beyond the specification. So all the units produced in this region will be rejections. But in both the scenario, what is the CP value? CP value is 1.67 here also. CP value 1.67 here also. By this, what do you understand? CP is not able to detect the shifting of the process. That's why I call it, a limitation. So to overcome this limitation, we introduce another tool known as CPK, which is nothing but, a formula you can see here. USL minus X bar by 3 sigma, X bar minus LSL by 3 sigma. We calculate a ratio on the right side as well as on the left side. If the process is not at all shifted, the right side ratio will be equal to left side ratio. But the moment the process is shifted, the ratio will have a difference. Once the ratio on any one side will definitely go down. Whichever side the ratio is going down, that is letting us know that the risk has increased. Let us understand. But right now, when you look at this slide, there is no shifting of the process. Can you see here? The process is centered properly on the target. So right side ratio, left side ratio, both are same. Both are equal to how much? 1.66. Whenever process is not shifted, you don't require CPK. Your CP and CPK will be same. Whenever process is not shifted, CP and CPK will be same. But now let us consider a shifted scenario. In this scenario, when you calculate CP, that will be 1.67. But look at your CPK. CPK is how much? 0.8. So now you understand your process is producing rejections or producing defects on the right side. Right? And now tell me. So now our decision making rule. To understand about the capability, look at CPK, not CP. Look at CPK and not CP. We want the CPK to be more than 1.67. If CPK is more than 1.67, you can immediately conclude your process is capable and consistent. But CPK is not more than 1.66. You need to understand your process is not capable, but may be consistent. In order to understand the consistency, you can look at the value of CP. If the value of CP is more than 1.67, then you can conclude your process is consistent. Right? So CP tells about the consistency, but CPK talks about capability. Why do we use different words? Because CP only makes use of sigma, but CPK makes use of X bar also along with sigma. All of you understand CPCPK logic?
Yes, sir.
Yes, sir.
Yeah. Now, one of you read this question, we'll see how the calculation happens. But you can use my calculator, sigma level calculator to solve this. But one of you, can you please read this or let us go to this problem. Question is simple. And who is going to read this? Come
For
on,
an
read out.
elect For an electronic manufacturing process, the specification for current flow is 100 plus minus 10 milliamperes. The process mean and estimated standard deviation are 107, 107 and 1.5 respectively. Compute CP and CPK.
Very good. Thank you, Gaurav. So Gaurav is telling that for an electronic process, customer has given current flow specification 100 plus or minus 10. So what is upper spec? 110. You can see here. What is lower spec? 90. Process average means H bar 107. Process standard deviation means sigma 1.5. Now you calculate CP. And how much is the CP? 2.22. What is the requirement? 1.67. What is the actual value? 2.22. The process is highly consistent. Can you see that? Process is highly consistent. Now you calculate CPK. For CPK, you have this formula. CP upper, CP lower. So you calculate CP upper, you calculate CP lower. So CP upper is 0.66, CP lower is 3.77. So out of when there are two values, you should choose the minimum value. So CPK is how much? 0.66. Now looking at the CPK of 0.66, tell me, is this process capable? Come on,
No,
is this
sir.
process
No, sir.
capable or not?
No, sir, it is not capable.
Not capable. That means there will be rejections. Rejection will happen on the right side because CP upper got reduced. Am I right? On the upper specification, your process will certainly cross upper specification limit. Please answer me this question. Is your process consistent?
Yes, it is consistent.
Because CP is very much
More than-
healthier.
Yeah.
That's all. Here after reading CP, CPK will be, easy job for you. So similar problem, upper spec, lower spec, process average, process standard deviation. Now CP equal to 1.11. Are you happy with the CP? Tell me, are you happy with the CP?
It is not consistent. It is below 1.67.
It's not up to the industry standard. Industry standard is 1.67. For critical process, it is 1.67. For non-critical process, it should be at least 1.33. But CPK is further worst, 0.66. So process is not capable, not consistent. Since CPK is under trouble, you can understand process is shifted. So move the process average or process mean closer to the target. Since CP is under trouble, you should also focus on reducing variation. Hope it is clear to everyone. Now answer me this question. Read the question and answer me. Hello, Roshni. Why you are not answering today? Are you there? Okay, others. What is the answer here? What action is needed?
So the capability has to be improved and the consistency also has to be improved.
So what should you do now?
So you have to reduce the number of rejections.
Reduce the rejection is the ultimate goal. Statistically, you should reduce variation because CP is not up to the mark. And you should shift the process mean towards target. There are two problems. Your car is bigger. It is better to change your car, number one. Changing the car means reduce variation. After changing the car, you must drive steadily in the center. You must drive steadily on the target. You're not supposed to take your car or drag your car to the left or right, which you're not supposed to do while driving. So we need a skilled driver. At the same time, we need a smaller car. These are the two requirements.
So it is to reduce variation and improve the process.
Yes, if CP is bad, that means your car is bigger car. The process is bigger by nature. And if CPK is under trouble, that means your driving skills are poor. You are driving towards the left or driving towards the right, which you are not supposed to. You must drive through the target. And now this is about CP, CPK, DPMO, and all of this. Now, any questions? I'm open to it. Otherwise, we
Sir.
can move on to the
Sir, one
hypothesis testing. Yes, please.
Sir, one question here. So, I mean, what my understanding is, if the mean will shift to the towards the target, automatically CP and CPK will improve.
Very good. If mean is shifted to the target, your both CP and CPK will improve, but that improvement is again limited by the variation, process variation. So you should focus on reducing the variation also. If you reduce the variation, again your see, please note, when I shift my process, CPK will improve, but not CP.
Okay, okay.
But when I focus on reducing variation, both CP, CPK will improve. In any given scenario, CPK cannot be more than or higher than CP. It will always be lower than CP. So these are some understanding. With that, you should be able to decide well.
Sir, one more question.
Ah.
By getting the value of CPK, can we tell the process is shifted to the LSL or towards the USL by knowing the value of CPK itself?
Yes, definitely. If you have all the calculations, you can say. And look at the CPK. Now, how
0.66.
much is your CPK? 0.66, right?
Yes,
But how did you arrive on 0.66? Before that, you got two value, 1.55 and 0.66.
yes, 0.66. So lower. CP
1.55
lower.
is upper side, 0.66 is lower side. That means which side your process is shifting? To the left or right? Lower side only, isn't it?
Towards.
So your process is
Yes.
shifting towards left. Now you understand just by seeing this value. These values are known as CP upper, CP lower. If your CP upper is going down, your process shifting to the right. If your CP lower is going down, your process is shifting to the left. Clear now?
Yes, sir.
Very good. So this also completes our measure phase. If there are any questions, you can ask. Otherwise, we must now move on to the analyze phase. So in analyze phase now, all of you are clear with the brainstorming and all, am I right? Or do you have any questions to ask in the, what do you call, in the basic tools, brainstorming, Y-Y analysis, or shall we directly go to hypothesis testing, all of you?
Yes, sir.
Okay. So in hypothesis testing, there are some basics. Null hypothesis, alternate hypothesis. So I want you to just watch this, introductory session. Then we will discuss to understand what is null and alternate, right? So let me see whether please confirm if there is any issue with audio or something, please let me know. Otherwise, we can have
an important tool called hypothesis testing. And there are two important terminologies associated with hypothesis testing. One is null hypothesis, another one is alternate hypothesis. So what is this hypothesis
you can stop
testing?
and ask questions
How it
whenever
is going
needed.
to be helpful in validating the root cause? That is what we are going to gain from this video. So first of all, hypothesis testing means it is a decision-making procedure. It's a decision-making procedure in which a claim about a difference, the difference could be in the material characteristics or
See,
difference could be in
normally
performance.
the hypothesis testing, what happened?
Right? A claim about a
Yeah,
difference.
just stop. Normally, hypothesis testing is performed after completing fishbone analysis, after the brainstorming session, because now that you have a lot of input have come from your team member, experts, and everyone. So whether all these inputs are really
Will be
correct or not,
tested for its trueness.
correct or not, shall we take action or should we take action or not? If everybody agrees to take action, then no problem. If people are partially agreeing and partially not agreeing, if there is a disagreement, then we go to hypothesis testing. So basically, the opinion available or the claim available is getting validated now, right?
Then you have two machines, machine number 1 and machine number 2. And people are telling that machine number 2 can produce faster than machine number 1. That means the production rate is different between the two machines. So whether this difference is really true or not, this question will get answered by hypothesis testing. So how do we get this question answered? We probably do an experimentation. We'll run machine 1 for 1 hour. Similarly, we'll run machine 2 for 1 hour. And then if we observe machine 2 could produce more product in that study period of 1 hour, then we will make a conclusion that machine 2 can produce faster than machine 1. That means based on the experimentation, a difference between two groups is validated, right? So hypothesis testing is basically a procedure to validate the difference that exists between two groups, right? So we will understand the deeper meaning of it by going through this video content. All right. So what is hypothesis testing? A claim about the difference between two or more groups is tested for its trueness in real life. Let us say you have 3 suppliers who are supplying some raw material to your company. And now why are you procuring from 3 suppliers? Because you believe that the incoming material quality is more or less same with all the 3 suppliers. So you work with all the 3 suppliers and then you procure your raw material, isn't it? Suppose if you feel like one of the supplier, he supplies the raw material with a much better quality, probably you will prefer working with that supplier and then cancel the contract with other 2 suppliers. So when you actually wanted to take a decision about the quality of the material, you will probably do an experimentation, isn't it? You will do some study with supplier 1, supplier 2, as well as supplier 3. And if the study gives a different result for a different supplier, then you will probably consider one of the supplier as good, and then the other 2 you might cancel, isn't it? So this procedure is called hypothesis testing. So what is this procedure? A claim about the difference between 2 or more groups is tested by conducting an experiment for its trueness in real life, right? Just because you observed something in an experimental study, it may not be true in real life. So you have to be very sure that whatever you observed in your experimental study, will also reflect in the real life. And for that, we have certain procedure and certain tools which will confirm that whatever you observed in the experimental study will also be true in the real life. Such a procedure is called hypothesis testing. Say for example, so this is the definition we understood. So hypothesis testing is a decision-making procedure in which a claim about the difference between 2 or more number of groups is called hypothesis testing. And it could be group 1 and group 2, or it could be a sample and a population, or it could be any number of groups, right? It could be machine 1 and machine 2. It could be factory number 1 and factory number 2, or it could be factory at north, factory at south, and factory at west. So whenever you wanted to validate, or you are in a doubt whether the difference exists between 2 or more group, then you can validate the difference using this statistical procedure called hypothesis testing. For example, see here, after conducting the brainstorming and the cause and effect analysis, the experts throw away a lot of inputs, isn't it? New input. And see here, these are all experts' opinion, or these are all can be considered as brainstorming result. The reaction time of a chemical process will affect the yield of the chemical process. That means if the reaction time is different, then the yield will also be different. And that is the statement, right? So that means the reaction time is suspected to affect the yield of the chemical process. So this is a statement, right? and pouring temperature affects the casting quality. And this is again another expert's opinion. And all these opinions, are they really true or not? And you can validate this statement by conducting an experimentation, which is called the hypothesis testing. So you don't have to believe all the opinion. Even if the opinions are given by the expert, you can still verify them and then you can validate them. If the opinions are found to be experimentally correct, then you can consider the opinion as fact, and then you can make changes in the process based on the expert opinion. If you are not able to validate the expert's opinion into a fact, then probably better don't make any changes based on the opinion you have received. Treat that as just opinion, and you don't have to make any changes. All right. So in order to understand hypothesis testing, you must understand these two terminology: null hypothesis and then alternate hypothesis. Basically, a hypothesis means a statement, and this statement can be of two types. One is null hypothesis, another one is alternate hypothesis. The null hypothesis is generally represented using the symbol H naught, and the alternate hypothesis is generally represented using the symbol H1 or HA. So these are the notation. So what is null hypothesis? Null hypothesis is the initial claim specified using common knowledge. When you have three suppliers, the company believes that all the three suppliers perform at the same level. So whenever you make a statement based on the common knowledge, isn't it? You have 10 machines, all same make and then same model. And what is your belief? All the 10 machines, the rate of production is same. All 10 machines will give same surface finish. So everything is same. So such a statement is called null hypothesis. We specify the statement using our common knowledge, right? Otherwise, you can also define null hypothesis as statement of no impact or statement of equality. You have 10 machines and all 10 machines are same in terms of the performance, in terms of production rate, in terms of surface finish, and all those things. So that means you can also say null hypothesis as statement of equality, statement of no change, and then statement of no difference. So always null hypothesis is to be assumed if you cannot reject it. If somebody says all the 10 machines are performing at the same level, we generally accept it, isn't it? Because they're all of the same make and then the same model, and so the performances should be same. But if somebody comes with some evidence of evidence after doing an experimentation, probably you will then reject your belief, and then the suspect on the difference will increase. So these are the ways you can define null hypothesis. And then alternate hypothesis. This is the statement that will be valid if the null hypothesis is rejected. Somebody carries an evidence, carries data based on experimentation. Now you will reject your null hypothesis, right? And then you will start believing on the experimental study. So alternate hypothesis or the statement of impact or the statement of inequality. Machine 1 production rate is different from machine 2, or machine 1 is faster than machine 2. There is an inequality, isn't it? So it's also considered a statement of change, statement of difference. Sometimes alternate hypothesis is referred to as the research hypothesis, because you will be able to make this statement only after conducting some experimentation, and so it is also referred to as research hypothesis. Now, let us understand the concept of null and alternate hypothesis with some example. I'll show you certain statement and then we will figure out whether it is null hypothesis or alternate hypothesis. The first statement: higher pouring temperature will increase porosity. That means the statement clearly tells that when you increase the pouring temperature, the porosity will increase. That means the pouring temperature is having an impact on the porosity. Probably if the temperature is more, the porosity might increase or it can even decrease. There is a huge impact, right? So it is a statement of impact. When I say it is a statement of impact, go back to the slide, right? Statement of impact. That means it is an alternate hypothesis, right? So pouring temperature has an impact on the porosity. It's an alternate hypothesis. When you attend our training program, your knowledge level will improve. Again, this is a alternate hypothesis, isn't it? Because the more the training you attend with us and more the knowledge you gain. So the training is considered to have an impact on your knowledge, isn't it? And so that's an alternate hypothesis. Whenever a factor makes an impact on your response, I mean on your result, then the statement should be considered alternate. Another statement. Calorie consumption will affect weight gain. That means if you consume more calories, then weight gain might increase. You reduce your calories, then weight might reduce, isn't it? So calorie consumption will definitely affect the weight gain. So it's a statement of impact. Speed of the car will affect the mileage. Again, it's a statement of impact. Reaction time affect the process yield. Again, it is a statement of impact. That means all these four statements are statement of impact, and so they are all alternate hypothesis. They are all alternate hypothesis. On the other hand, when I say like this, pouring temperature has no impact on porosity. Whatever temperature you pour, the porosity is going to be same. That means pouring temperature doesn't have any impact on the porosity. It's a statement of no impact. Calorie consumption is not responsible for the weight gain. Whether you consume more calories or you consume less calories, the weight is found to be same. That means no impact. Calorie consumption has no impact. Again, it's a statement of no impact. Speed of the car will not affect its mileage. You drive the car at whatever speed you want, the mileage is same. If you say like this, it is again a statement of no impact. Reaction time will not affect the chemical process yield. Whatever is the amount of time you allow the chemicals to react, the final yield is going to be same. So if you carefully note all these statements are statements of no impact. The statements of no impact are called null hypothesis, right?
Do you understand, all of you here? How to frame null hypothesis and how to frame alternate hypothesis?
So you can define the null.
Tell me. All of you, can you understand this?
Yes, sir.
So any questions so far? All good, so going good so far, right? So let's complete the remaining part of the video also, and then we'll continue. Okay. Yeah, here it is.
Null hypothesis based on the impact. And another thing, based on equality, right? Now the previous example was based on impact. Now it is based on equality. When I say equality, it is like mathematically you will be able to put an equal to symbol. Inequality means there will be higher than or greater than or smaller than symbol. Let us understand that. Supplier 1 deliver faster than supplier 2. That means it is a statement of inequality. Supplier 1 deliver faster than supplier 2. That means he consumes only less time to complete a task, and then he quickly delivers. Machine 1 produces parts faster than machine 2. Again, it's a statement of inequality. Polling rate of northern region is more than the southern region. Again, it is a statement of inequality. Transaction time of vendors are not same. You have 3 vendors and transaction time are not same. They're all different, right? Probably vendor A consumes less time and vendor B consumes moderate time and vendor 3 consumes more time. So all these 4 statements are examples of statements of inequality. Statements of inequality are also considered as alternate hypothesis. Now, let us see some more statement. Delivery time of supplier 1 and supplier 2 are almost same. There is a difference, but I don't see that difference as significant. That means the delivery time is almost same. It is a statement of equality. Machine 1 and machine 2 produce parts almost at the same rate. This is again a statement of equality. Polling rate are almost same in both northern and southern region. This is again a statement of equality. Transaction time of vendors are almost same. Again, it's a statement of equality. All these four statements are statements of equality. Statements of equality are nothing but null hypothesis. Now, if you want to express the statement mathematically, for example, first statement, delivery time of supplier 1 and supplier 2 are almost equal. How can you write it mathematically? Delivery time of supplier 1 is equal to delivery time of supplier 2. When you express a statement in mathematical format, equation format, and if you can get an equal to symbol, definitely that is null hypothesis. Coming to the same example with the alternate, supplier 1 deliver faster than supplier 2. That means delivery time of supplier 1 is less than the delivery time of supplier 2. He consumes less time and then delivers. That's why we say supplier 1 is faster. Supplier 1, delivery time of supplier 1 is less than delivery time of supplier 2. Whenever you get less than or greater than symbol in your equation, the statement is alternate hypothesis. Hope you have clearly understood what is null and what is alternate and the difference between null and alternate. Null is statement of equality. Alternate is statement of inequality. Null is statement of impact. Sorry, null is a statement of no impact and alternate is statement of impact. And null is statement of no difference and alternate is statement of difference, isn't it? All right. So what is that we learned? Hypothesis testing is a decision-making procedure in which a claim about a difference is validated. Whether the difference what we observed in the experimentation, will it be an actual difference in the real life? So that question gets answered after the hypothesis testing, nothing but a small experimental study. Hypothesis testing is an experimental procedure to test whether the difference observed in the experimental study is a true difference in real life or not. Null hypothesis is a statement of no impact, is a statement of equality, is a statement of no difference, right? It's a statement of no difference, no impact, no difference, equality. Alternate hypothesis is a statement of impact, statement of inequality, and statement of difference. Null hypothesis is a statement made using the common knowledge. Alternate hypothesis is a statement made using the impact observed from an experimental study. Whatever we observed in the experimental study, and then we believe on it. And whatever the statement that supports what you observed in the experimental study, the difference what you observed in the experimental study, if you believe and then make a statement, that is actually alternate hypothesis. Hope the lessons are very clear and between null.
Okay. So come on, all of you, tell me what is null hypothesis and what is alternate hypothesis. So what's your understanding here? Come on. Come on, all of you, let us have some interaction on what we learned right now. Can you frame a null hypothesis for your project now or an alternate hypothesis? So may I have all of you on video. Now the null and alternate, is it very clear?
Yes, sir.
Now tell me, give me a scenario. Let us talk in terms of null hypothesis and alternate hypothesis. What kind of, are you working on any project? Are you studying anything? You have two departments. You want to say that one of the department is performing significantly better than other department. Let's say you have two team and you are the group leader. You want to offer increment to one of the team which is performing better. Now this is a scenario for hypothesis testing. You can't just like that give increment to one of the team randomly. then what will happen? That will definitely kill the morale of the team. So you have to refer to the data and see that the statistics also supports your decision. And now you have two teams and you are comparing the performance, and whichever team is performing better, you are going to give increment to that team. A better increment to that team, and for the other team, a normal increment. Now, what is your null hypothesis in this case? I don't know why you people are not participating at the very important, point of the training program. This is the main essence of analysis space.
Sir, I'm
Yeah.
not 100% sure, but null hypothesis would be that you're giving increment to everybody.
Known to everybody. Okay, there are different ways, I have explained you. It's a statement of equality, statement of no impact, statement of no difference, or it is a statement of innocence. If you simply say that both teams have performed, equally, these are all statement of innocence, statement of equality. So null is performance are same. Then what is alternate?
When performance is not same.
Wow, one of the team's performance is significantly better than the other team. It can be team 1 or team 2, team A or team B. Now you know how to frame null hypothesis or alternate hypothesis. If I add Virat Kohli in the team, the chances of team winning the match is higher. What is the statement?
This is
Null or
that
alternate?
That's an alternative.
alternate.
Alternate. That means the factor you are studying is Virat Kohli. The presence or absence of the factor can make a difference in your result. And that difference is not an average difference. It's a significant difference. You can feel it, isn't it? So you have an option to use two types of cutting tool. Cutting tool type 1 and cutting tool type 2. And you want to claim that the type 2 cutting tool can give a better surface finish. Right? And now your company so far believing that all cutting tools will give only, the same surface finish. But now you are suggesting your company to change from the old cutting tool to the new cutting tool. So in order to influence the change, they will obviously expect some evidence. Then only they will scrap the old one and then move, place order for the new one. So now you have done a study, right? You have done a study. That means you made some parts with the old tool. You also made some parts with the new tool. And now with the help of the data, you are going to support your claim. Now, what is null hypothesis in this case? Surface finish, old cutting tool, new cutting tool. Frame a statement using your English. Come on.
Surface finish would be same if we use new cutting tool or old cutting tool.
Very
Surface-
good. Very good. That is null.
Yeah, that is
The
null.
surface finish with old cutting tool is equal to the surface finish with the new cutting tool. If I replace the equal to symbol with the inequality or use greater than symbol or less than symbol, then it becomes alternate hypothesis. Very clear? So with that, see if, okay. Oh, module 3 now, So we should go to module 3. Analyze. Very good. We have done with all of this. So let us move to hypothesis testing. Yeah, here. So null and alternate is perfect. Now we move on to this. What is this? Type 1 error and type 2 error. and confidence level and power of the test. Very, very important. So we are going to understand this. Now let us understand the type 1 error and type 2 error with a simple scenario, a manufacturing scenario. Imagine you are manufacturing product and you are dispatching your, batches after every shift. And at the end of every batch or every shift, you study some sample and make a judgment about the quality of the units as a batch, or you call it a lot. Now you studied a sample and you take a decision about the lot. The lot is the population. Sample is the units you are inspecting. Imagine, based on your inspection, in case you reject a good lot, what are you doing here? You studied some sample, but your decision is now going wrong. The lot is good, but you still reject it. Now, who will be the loser now? If a good lot is rejected by the inspection team, who will be the loser, manufacturer or consumer?
Manufacturer. They're losing on the cost.
So this is known as manufacturer's risk. This is known as manufacturer's risk, otherwise known as type 1 error. Sometimes people also call it false positive. These are different names, but ultimately meaning manufacturer's risk. One more possibility of error is also there. The lot may be bad, but your quality team might study a sample and sometimes accept a bad lot. If you accept a bad lot, the bad lot will enter the market or will reach the customer. Now, who will be the loser? Consumer risk. Always when you are experimenting, you are only dealing with the sample. Am I right? So type 1 error and type 2 error will certainly happen. Type 1 error and type 2 error will certainly happen. You must see to that you are limiting such errors to the permissible level. The normal permissible level is 5% for alpha and 5% for beta. 5% alpha means 95% of the time, a good lot must get accepted. Am I right? If alpha is permissible, alpha is 5%, that means the expectation is 95% of the time, a good lot should get accepted. Which means if you write exam well, 95% of the students who are writing the exam well should be passed in the exam. This 95% is known as confidence level. What is my confidence level? The probability of passing the real qualified student. But 5% of the time, what happened? In spite of students writing the exam well, the teacher might be failing. So these things, we have to fix before making a decision. Normally, it is fixed at 5%. Similarly, consumer risk 5% means, beta risk 5% means, remaining 95% of the time, a bad lot must be correctly rejected. That is known as power of the test. All of you are with me on this? Now tell me, what is alpha risk? What is alpha risk?
Risk of manufacturer.
Risk of rejecting a good lot or bad lot?
Risk of rejecting a good lot.
Risk of rejecting a good lot is known as manufacturer's risk. The risk of accepting a bad lot is known as
Consumer's risk.
consumer's risk. If manufacturer's risk is 10%, then what is the confidence level? What will be the confidence level?
90%.
90%.
90%.
So these are the rules of the game, as far as the hypothesis testing is concerned. And every game has got a cricket, right? Has got a rule, right? Same manner, in hypothesis testing, these are the rules. You must play with the rules. You have to decide the alpha beforehand, before conducting the experiment. If you decide that alpha is 5%, that means you are aiming for a confidence level of 95%. Right? All right. Now I want to change this scenario for hypothesis testing. This is a manufacturing scenario. Can you see that? Very easy to understand. Rejecting a good lot is manufacturer's risk. Accepting a bad lot is consumer's risk. In hypothesis testing, manufacturer's risk is known as type 1 error. And consumer risk is known as type 2 error. In manufacturing scenario, we used words like, good lot, bad lot, goods and sample. But in hypothesis testing, we will replace the lot by the word null hypothesis. We are not going to talk about the lot. We are going to talk about null hypothesis. And now I show you. See here, reality about H naught. H naught means null hypothesis. Your null hypothesis is true. But after doing the experiment, because your experiment says you reject a true null hypothesis. Now the error you are committing is type 1 error. All of you are with me on this? Rejecting a true null hypothesis is type 1 error. Similarly, accepting a false null hypothesis is type 2 error. Please think about type 1 error scenario. What is committing type 1 error? Null hypothesis means company's belief. Yes or no? What your company is believing is correct. But you did some experiment and you are telling that company's belief is wrong. That means you are trying to mislead your company, isn't it? By doing an experiment. This is what we term it as or call it as type 1 error. All of you are with me?
Yes, sir.
All of you are with me.
So
Yes.
can you give
Now-
an example of this? It's little complex to
Okay.
implement.
Let us say your company is working with 3 vendors. What is the belief your company is having? Your company believes that the performance is equal with all 3 vendors. That is why you have you have signed with the 3 contractors, isn't it? You can buy from contractor 1 or vendor 2 or vendor 3, and you always believe that the performance are equal. But now that belief is correct, but you refer to some last 3 months data. The last 3 months data is supporting vendor 1. Last 3 months data is supporting vendor 1. So now, according to the data, you must cancel the contract with vendor 2 and 3.
Three.
But just because your data is telling, you actually cancelled vendor 2 and 3. But what happened after you cancel the contract? The vendor 1's performance, in the upcoming months is also found to be, very poor. Now, what do you realize?
Now we
Your
don't have any
experiment-
vendor left. 2 and 3 also we have cancelled.
2 and 3 cancelled. Now you are working with only 1, and 1 is also not performing well now.
Hmm.
See, always performances are expected to go a little up and down. At the time you studied, a small period only you studied. That point of time, 1 seems to be better. It was slightly on the upper side. But in the subsequent months, the 1 also started performing badly. So what happened? Your experiment has led you in the wrong direction. Just because you have seen something in data, it doesn't mean that it is always correct. No. See, for example, imagine you are writing an exam, MCQ exam, all multiple choice questions. You are answering all the questions. No, you are choosing the answers without reading the question. You are choosing the answers without reading the question. But after you submit the exam, you are getting a pass mark. Possible or not? Come on, tell me.
Possible.
Some chance is there. Just because you see something in your experiment, it doesn't mean that that will be the case always. This is called luck factor or random factor. This is called luck factor or random factor. So a random factor generating the data and our decision going wrong is what is, type 1 error. This can happen in any experiment. At the time of study, your data will give some information. But in other times, it will give a completely opposite information. Possible. So that risk you should know. And that risk we are limiting using this alpha. If it is less than 5%, we are okay. That means 5% of the time, if you are taking wrong decisions, that is acceptable normally, industry practice. But 95% of the time, whenever you reject the null hypothesis, you must reject it carefully, right? So a true null hypothesis, if you should never reject, right? So that is type 1 error. That means 95% of the time, your true null hypothesis is always accepted, right? Coming on to the other side, null hypothesis is false, but you still accept. The company's practice is wrong, but you are not able to prove it wrong. You did an experiment, and with the help of the experiment, you are not able to prove that the practice is wrong. That means you are also now aligning with the company's belief, but actually the belief can be wrong. And now you are committing type 2 error. This is called beta risk. This is called beta risk. And so the rest is called the power of the test. If beta risk is 5%, then power of the test is 95%. What is power of the test here? 95% of the time, a false null hypothesis is correctly rejected. Now let us take a real life example. Imagine you have to buy a rice bag for your family. A 25 kg rice bag your mother has asked you to buy. So now there is no branded item available nearby. So anyway, you are going out and you are searching for a store and rice is available, but all are unbranded. That means you are not sure about the quality. Now, how will you purchase the rice bag? Will you purchase it blindly or will you do some study and buy? Come on, tell me.
We'll do some study and ask
Yeah.
people who did
We'll
the
take some sample. Sampling.
You will take some sample.
Yeah.
Now your sampling technique is coming into picture now, right? And you take a sample and study it. And if you look at the rice, you taste it, you do all of this. And if the sample is good, you will end up buying the rice bag. Because why are you doing this? Because you can't study each and every rice grain. Isn't it impossible? You can't sit down and do it for 7, 8, 5, 6 days. Not possible. So you purchase the complete rice bag. And now the rice bag is handed over to your mom. And your mom started cooking the rice, but the food is not good. But you tested already the quality with your sampling, but every time a meal is cooked and you are getting scolded by your mom. Now what happened? What went wrong now?
Sampling technique.
Your sampling technique. There is a limitation always, isn't it? In any study we do, there could be some limitation. Your sampling, power is not good enough. It doesn't have enough power to reject a bad lot. Yes or no?
Yes.
The lot was actually bad, but you took only sample from the top layer, but all the rice, inside of the bag has lot of, foreign particles and the taste was also bad, but the fellow cheated you. Now the problem is with the power of the test, isn't it? A bad lot is getting accepted. Same, the reverse can also happen. If you over-inspect, if you over-check a lot, you might sometimes end up rejecting a good lot also. That is also possible. Possible or not? This is what we call it type 1 and type 2 error. Your mom scolding you is a case of you
Type-
committing
Type 2 error.
Type 2.
But in hypothesis testing or in any workplace, type 1 error is more sensitive because manufacturer is directly getting affected. Here, consumer is getting affected. Of course, both we need to control. But your company will be always interested in, their worry, their problem. Type 1 error must be limited. They say that it should be always below 5%. What is the meaning of 5%? At least 95% of the time, a good lot must get accepted. With the lot and sample, it is easy to discuss, easy to understand. But with the statement, Can one of you define type 1 error? Who is going to do that? Define type 1 error, but don't talk in terms of lot and sample. Talk in terms of null hypothesis, true and false. Come on, who is going to define type 1 error? What is type 1 error in hypothesis testing? Who can try? Shaguraj, Pisal, can you try this time? I'm seeing you not at all speaking. Prabhagar K or Tejaswini Naidu. Come on. See, all of you believe that whether you interact or not, you get the same amount of knowledge. It may be true or false, isn't it? What is the statement? Whether you interact or not, you get the same amount of knowledge, you get the same certificate, and the level of success will be same. This is null hypothesis, a statement of innocence. Isn't it? If you interact well, then obviously your learning will be more. The certificate will be meaningful and you will start seeing results. That is alternate hypothesis. All right. Anyway, now please talk in terms of null hypothesis being true or false and try to define type 1 error. Who can try now? It is definitely a confusing topic only, I agree. But you have to digest it and you have to be very clear about it. Okay. And as usual, these people can try. Gaurav, Roshni, Adib, or Minalini is also seem to be active. Who is going to try?
It is a bit complex, but I will try. So type 1 error is, as you have given example, if correct thing is rejected more than 5%, means the process or the lot, if it is well within the limit of 95%, means it is passed 95% at least, then it is okay. If it is rejected more than 5%, the good process, if it is rejected by more than 5%, then it is type 1 error.
Yeah. Good try. Good try. Whenever you reject a true null hypothesis, please note you are committing type 1 error. Whenever you reject a true null hypothesis, you are committing type 1 error. And the permissible risk is 5% only. Permissible risk is 5%, which means there can be 5% chance your decision can go wrong. Your decision about null hypothesis can go wrong. 5% of the time, 5% risk is generally permitted. But you should not keep more than 5% as the risk of you rejecting a true null hypothesis. So the probability calculation comes into picture. That is why you are finding it difficult. We need to calculate the probability. So we'll see that. And what is type 2 error?
Sir, I'll try. When like just the opposite I'm doing, when a false hypothesis is accepted, that can be counted as a type 2 error.
Very good. The probability of accepting a false null hypothesis. The probability of accepting a false null hypothesis is known as type 2 error. So keep this in mind always, and automatically you will be able to define confidence level and power of the test. Right? And the symbol for type 1 error is the permissible level is known as alpha. We also call it as level of significance. 5%. 5% is granted. You can utilize that 5% area, but never keep the chance of your decision going wrong more than 5%. Say for example, you got 10 lakhs. A bank is telling that you invest in our bank and we will give you 25% interest per annum. And now they are also telling that your money will be invested in share market and that's how they are giving you 25%. There is no guarantee here. Can you see that? Now, what do you understand here? If I invest my money Now rate of interest seems to be very attractive, but it's not 100% guaranteed. Can you see that? But still you want to invest. Now tell me, if you want to invest, do you decide to invest by knowing the risk involved or without knowing the risk involved? By knowing the risk involved, isn't it?
Yes.
You know that, okay, the definitely 90% chances are that my returns will be attractive. But I also know that 10% chance is there that I may even lose my deposited money. Yes or no? So you will have some principle for investment, isn't it? You will say that if the risk is 5%, okay, I will invest. But whenever, whatever be the, what do you call, the investment opportunity, if the risk is more than 5%, I will not invest. This is your way of working. This is your way of decision making. Similarly, in hypothesis testing, every company would like to keep the alpha as 5%, which means 5% risk they are ready to practice. But more than 5%, you should never commit type on error. So that is the idea. So now let me continue with your slides. And now you can understand how much is the quantum of type 1 error. How much is the quantum of type 1 error by using a tool known as p-value or probability of significance, right? And now you have a definition here, p-value. What is the definition? See here the third definition. P-value is an estimate of type 1 error we may commit while rejecting null hypothesis. P-value is an estimate of type 1 error we may commit while rejecting null hypothesis. Or also read the first definition. P-value is the probability that the calculated statistics is equal to the observed value or beyond it. That is one thing. P-value is the risk of observing the data due to a random chance. Random chance, hinky-punky, but still getting pass mark. That's a random chance. So you might conduct some experiment and data could have been generated randomly. Data might be favoring something, but actually, the fact is not, what your experiment is saying. So this is what we call it as p-value. And if this p-value is lesser than 0.05, you can reject the null. But whenever the p-value is more than 0.05, better don't reject the null. This is the guideline. So now I'll give an example so that you can easily understand. Tell me, what is Virat Kohli's batting average in One Day International? What is his batting average?
58.
E plus.
58.
Uh,
58, right?
Mm.
Okay. And what will be the batting average Virat Kohli might get if he plays another series of 10 matches? Will it be exactly 58? No. It will be 58 plus or minus. Why this plus or minus is coming?
Because of variation. Because we
Because
can't.
variation. If you look at the past performance, there is variation in the Virat Kohli's performance, isn't it? It's not always 58. Sometimes it is 59, sometimes it is 60, sometimes it is 54. He scores different runs in different matches, and so the average is also moving up and down. So now, because of that, you are now saying that the next series average will be 58 plus or minus some value. Just for discussion's sake, let us say it is 58 plus or minus 5 runs. Batting average is going to be 58 plus or minus. And now I will ask you how much confident you are to see that Virat Kohli's batting average remains in this range. Definitely people will ask, this question. Now you may say my confidence level is 90%, 95%, or 99%. If you are too much confident about if Virat Kohli is too much consistent, then your confidence level will go high and high. If Virat Kohli's confidence is consistency is a little down, then your confidence level will also go down. Isn't it? Instead of Virat Kohli, if I put some other player, let us say our Surya Kumar Yadav, now your, the average will also go down, your confidence level will also go down. But definitely he cannot maintain a batting average of 58 like Virat Kohli. And your confidence level will be very, very low with him. But consider Virat Kohli, 58 plus or minus 5 is the range in which you expect his batting average to be in the next series. And when I ask you how much confident you are, you will tell me that, sir, I am 95% confident. That means what? You are still doubtful by, you are still 5% doubtful that Virat Kohli may not be in that range. Either he may exceed the range or he may go below the range. Isn't it? This is what, we call it, the, what do you call, the risk in our decision. This is the risk involved. So we are expecting something. So now imagine we are now bringing a factor now. The factor is we are appointing a coach. We are appointing a coach from, let's say South Africa. The South African coach is working with Virat Kohli for a considerable period of time, let's say 3 months. And now I want to study whether the addition of a new coach can boost the performance of Virat Kohli, batting performance of Virat Kohli. So after 3 months of coaching, Virat Kohli is now playing, and now his batting average in the next series. Normal batting average is how much you said? 58, right? But after the addition of the South African coach, his batting average has increased from 58 to 59.5. Now the coach want to make a claim. The improvement in the batting average of Virat Kohli is because of the coaching given by the coach. Are you in a position to believe the claim? Or are you doubtful?
We don't have any evidence that.
Because the past data clearly says, without doing anything, Virat Kohli's average can move anywhere from 53 to 63. Because it is 58 plus or minus 5. That is our understanding, isn't it? So any observation within this 95% confidence interval, the 53 and 63 are known as confidence limits. Whenever you see your statistics or experimental statistics falling within the confidence limit, we don't see any significance. Am I right? But suppose, imagine another scenario. A coach from New Zealand is appointed now for Virat Kohli. Now this coach is working with Virat Kohli for 3 months. And now another series Virat Kohli is taking. Now this time his batting average is increased to, from 58 to 67. And now will you be able to agree? It is because of the addition of the New Zealand coach, Virat Kohli's batting average has improved. Will you be in a position to agree now?
Yes.
Yes.
Because the statistics has gone beyond the confidence limits. See, still our decision can be wrong. Please note, Virat Kohli on his own could have pushed his average. That could have happened, we know. But in spite of that, we want to give the credit to the New Zealand coach. Because statistics is also supporting. Can you see that? So whether my experimental data is supporting a claim or not, for that you need to conduct experiment, calculate some statistics. Statistics can be average, statistics can be proportion, statistics can be any calculated value is known as statistics. You just check whether your statistics is falling inside the confidence limit or outside the confidence limit. Now please tell me, what is the probability for your statistics to fall inside the 95% confidence limit? What is the probability for your statistics to fall inside the confidence limit? Tell me. You told me, no, for Virat Kohli, you are 95% confident. That means what? Your confidence level is 95%. So the probability of the statistics to fall inside the confidence limit is 95%.
0.5.
I ask another question. What is the probability for your statistics to fall outside the confidence limit?
5%.
5%. This is what is known as, the p-value, probability of significance. Whenever your statistics goes outside the confidence limit, the chances of such event is less than 5%. Yes or no? The maximum available probability itself is 5%. If Virat Kohli's average has to go beyond, the chance for that event to happen is lesser than 5%. Whenever you understand that the associated probability, we call it probability of significance. If that p-value is lesser than 0.05 or p-value is lesser than 5%, you can understand the statistics has exceeded the confidence limit. Now you can believe your experiment. Clear? Now you can believe your experiment. In all other cases, better don't believe the finding. Rather, continue with the null. What is null? No impact. The addition of the coach has produced no impact. There is no improvement in the performance. Simply because the statistics is within the confidence limit. This is what you have studied in my slide also. And I think after Virat Kohli's example, it is easier now, isn't it? Probability of significance. And all these formulas, all these statements. And this is the decision-making rule. Whenever the p-value is less than 0.05, you reject the null. Whenever p-value is more than 0.05, don't reject the null. Continue with the null. All right. So now, let me also write something here. Yeah. See here.
So just to confirm, when the probability, so when p is greater than 0.05, that's when the probability has exceeded the experiment.
Yes, yes.
Right?
Wait. I will give an example. Now look, can you see the bell curve? The bell curve represents Virat Kohli's performance. What is the center? 58.
Yes, 58.
And the total area under the curve. What is the total area under the curve?
53.
100%.
63. 100.
What is the total area of the earth under the sun? 100% of the earth. Isn't it? Similarly, total area under the curve is 100%. Now, 95% of it I want to mark now. Right side, left side. The right side is 63, left side is 53. Do you understand? That means there is 95% chance for Virat Kohli to maintain his batting average between 53 to 63. But only 5% chance is there for Virat Kohli to exceed this. This is what our data is conveying to us. Clear? Now, in a particular match, Virat Kohli scored 59%. Or in a particular series, his average is 59. Now imagine his average is 59. Oh God, I draw a line here. When I draw a line here, this line is, the observation. My statistics is here. Now, what is the area to the right of the line? This is the curve. Here, what is the probability to the right of the line? This area, will it be more than 5% or less than 5%? More than 5% or less
5%.
than 5%? Tell me.
Less than 5%?
Should be
No,
more
see,
than
I
5%.
am asking a question. You know about the curve and Virat Kohli's score is here, 59. And where is 95% is coming here? Here only 95% is coming. That means beyond this only 5%. But you are still here. Now, what is the area to the right of this particular line? Already here you have 5%. Something else you have here. Some more chance you are here. You have here, isn't it? So
Yeah.
when Virat Kohli's batting average is here, the chances of this event happening is more than 5%. But if he performs somewhere here, you can easily understand he already crossed this line of significance, isn't it?
Yes.
Now the area to the right side is
Less
less
than.
than 5%. This is what we use it for decision making. You will see here now. When p value is less than 0.05, we reject the null. When p value is more than 0.05, we don't reject the null. So p value is a tool that just tells you where is your statistics. Is your statistics inside the confidence limit or outside the confidence limit? If it is inside the confidence limit, don't reject the null. But if it is outside the confidence limit, you can reject the null. Clear, all of you?
Yes.
All right. So now we will take some case studies based on our understanding. And
Sir,
for
in
that,
this,
yeah,
sir, in this
yes.
Virat Kohli example, what will be our null factor, or what will be the null?
Null hypothesis, I'll write here, H naught. The batting average of Virat Kohli with coach is equal to batting average without the coach. The batting average with the coach and batting average without the coach are equal. There is no significant improvement in the batting average. That is null. There is significant improvement in the batting average because of the appointment of the coach. That is alternate. When you communicate impact, that is alternate. When you communicate no impact, that is null. Perfect.
Understood, sir.
So now we have to consider cases. Now all of you tell me, all of you, do you know Maggie was banned sometime in which year it was banned? 19 or 2015, 7 years before?
No, I think 1 or 2 years back, 2 or 3 years
No,
back.
16 or 17 only, correct.
15, 16 only, some 5, 7 years before. Why
Yeah.
Maggie was banned?
Due to the presence of MSG,
MSG.
monosodium.
Presence of, very good, you know the story. Presence of MSD, MSG, monosodium glutamate. And another factor is lead content. Lead content is a measurable characteristics. FSSAI will have a guideline. Lead content, because they know maintaining exact level is not possible. They always give a range, am I right?
Yes.
So much ppm to so much ppm. So Maggie was maintaining it. There were no problem. It was selling well. They cracked the market. They were number one. But in the year 2015, a particular batch or a particular point of time, a food inspector doubted that, this is harmful. So he randomly selected, purchased some sample and tested them in a laboratory. And he found that the lead content are abnormally high. Abnormally high means he has seen the lead content outside the interval. That motivated him to go against Nestle. If he has seen the value little inside also, he should have dropped his idea of going against Nestle India, isn't it? He actually gone against Nestle India. So one more round of study is done. Few more samples are purchased, again random sampling. And they were sent to another laboratory. Again, another laboratory also confirmed the same thing, that lead content is higher. Now Nestle India also accepted. They accepted their mistake. Yes, sir, we are wrong. Something went wrong with our process. A particular batch did not meet the FSSAI guidelines. And so we are ready to, what do you call, recall our Maggie packets in the retail market. Several thousand tons, I believe, maybe, thousands of tons, because, such a huge, market they have in India. All the packets were recalled and they have to scrap it. Tons and tons of product, but how many packets they studied?
Just few.
Few
10
hundred.
packets, 100 packets,
Mm.
but hundreds of tons of Maggie packets were destroyed just by studying few samples. The procedure they followed is hypothesis testing. Because they have seen a statistics outside the confidence limits. Correct? They have seen the statistics outside the range, and that they have confirmed, by going for, two times they have seen the same thing. So that has helped them to take a decision. And now here, the null hypothesis, what is null hypothesis? Lead content is as per the spec. Lead content, everybody believed it. They all purchased and then they were cooking Maggie and happily eating, simply believing. Null hypothesis is always like that. Nobody questions null hypothesis. That is printed on the Maggie packet also. Lead content, so much. Everybody believes that. But that food inspector, his name is Sanjay Singh. So he is intelligent enough, to study, and then he questioned it. So his statement is alternate. Lead content is beyond the specified limits. That is alternate. And he is able to reject the null. He is able to reject the null. Please note, if you have a process, what is the chance of your products going outside the spec? Very less chance is there. Am I right or not? That is what is defined alpha. Very less chance is there, but every random sample I take, that is carrying that value. That means the whole process got deviated. Isn't it? I took samples of 30, 40 packets and I calculated lead content and I calculated average lead content. If the average itself can go beyond the specification, that means the process got affected. And so Maggie was punished, recall was announced. Maggie lost 80% market share in the same year. And they have to get it reapproved and then they have done. And this is a case of a one sample t-test. The Maggie example is a case of a one sample t-test. Because a sample is studied to judge a population. A sample is studied to judge a population. Clear, all of you? Suppose you want to compare Maggie, the lead content of Maggie, with another Maggie company. Can you tell me what is another competitor for Maggie? Top ramen?
Yippee.
Raman,
Yippee.
ITC,
Yippee is a good
Sunkiss.
competitor. If you compare the lead content of Maggie against lead content of Yippee, the study becomes two sample t-test. If you study a sample against population or a sample against a specification or a reference value, it is one sample test. If you study a group or a sample against another sample, it is two sample t-test. If you want to compare Maggie, Yippee, and one more company, who is one more competitor?
Indonesian, top ramen.
Top
What is
ramen.
it? Top
Top
ramen, right? Okay, so Maggie, Yippee, top ramen. Who is maintaining a better lead content? Now, three groups you want to study at a time. Now you can study simultaneously. When you are comparing three groups at a time, it is known as ANOVA. More than two, whenever the number of group is more than two, you can go for a study known as ANOVA, analysis of variance. Clear, all of you? One sample t-test, two sample t-test, and then ANOVA. When will you go for ANOVA one sample t-test? When you compare a sample against a reference value. A prescribed value is there. You are checking whether the sample value is within the prescribed value or not. And when you compare one sample against another sample, that is two sample t-test. When you compare more than two groups, that is known as ANOVA, analysis of variance. Now, consider the one sample test. You need to understand something there. If you are a food inspector who is outside Nestle, you're not part of Nestle. Now, the population characteristics are not known to you. Am I right? Since you are not allowed to access the information about the population remains an unknown population to you. Do you get my point? Population is unknown. So, but still, you study only the sample and understand the characteristics of the population. When the population is unknown, that's the time you go for one sample t-test. Suppose if population becomes a known population, let's say you are working inside Nestle, you are the quality head. Company is ready to share all the data. All the Maggi packets they have been producing, the data is readily available and they are ready to share with you. That means population average is now revealed to you. Population standard deviation is also revealed to you. When population characteristics are revealed, particularly standard deviation is revealed, your decision can be much more accurate now. And when you use population standard deviation for your decision making, your hypothesis testing will now be called as one sample G test, not a T test. So G and T, the difference is whether the population is known or unknown. If population is known, you go for G test. If population is unknown, you go for T test. But please note all the tests I have been telling right now. One common thing is lead content. Lead content is a measurable characteristics which is continuous data. All these tests are applicable only for continuous data. MSG present or absent, that is discrete. But lead content, how much lead content? Measurable, continuous data. For continuous data, 4 hypothesis testing just now I introduced. One sample G, one sample T, two sample T, and finally
ANOVA.
ANOVA. So we will try to see examples, make some calculations, and take decision after a short break. All right. So we'll take 10 minutes. Okay.
Yes, sir.
See here, a cooking oil manufacturing company claims that the fat content is 15%. Now the null hypothesis is fat equal to 15%. Alternate hypothesis, there are 3 options. You can say not equal to, you can say more than, you can say less than. If you say not equal to, it will be two-tiled. If you say more than, it is right-tiled. If you say less than, it will be left-tiled test. And this is suitable for either a one sample G test or T test. Why 2 options are here? If the population standard deviation is known, you can go for G test. If it is unknown, you can go for T test. This is similar to the Maggie case. Am I right? Yes or no?
Yes, sir.
Now another scenario. There are 2 vendors serving a company. You want to assess them based on the transaction time they take. Now the null hypothesis, transaction time equal, unequal, more than, less than. This is the scenario for 2 sample T test. You might have come across similar scenario many times. All of them are hypothesis testing only. And now you have 3 suppliers. Supplier A, supplier B, supplier C. Again, you want to measure their performance using transaction time. When the transaction time equal means null, not equal means alternate. Since there are more than 2, this is known as ANOVA. Clear? Please note all of you. So far, all the example, the data type is continuous. Can you see that, all of you? Data type is continuous. If the data type changes, then you have some new other test. Say, for example, now we are talking about response rate. What is the definition of response rate? Number of people responding. For every 100, how many people are responding? Or every 1,000, how many people are responding? Imagine you are running a digital campaign, digital marketing campaign. And out of every 1,000 people you reach, 65 people respond. That means what is your response rate? 6.5. Now you want to develop a new campaign which can give a performance better than the 6.5%. So now alternate hypothesis is written here. Now the response rate is not average. This is known as proportion. Now it is one proportion test. And you have two groups. One is male, other one is female. And here you are comparing the buying proportion. Whether people are coming for window shopping or people are coming for actual buying. The percentage of men buying and the percentage of women buying. That study is conducted and you want to make a statement. I mean, you want to make a conclusion. Yes, percentage of men are buying more than women, or percentage of women are buying more than men. Some conclusion you want to make. And that scenario leads to two proportion test. If there are more than two groups you are comparing at a time, let's say you have 4 offices, north, south, east, and west, and the percentage of defectives or percentage defects of one office is compared against other, and you want to find out any specific office or any specific regional office is performing, is committing more defect percentage. Now, defect percentage is proportion. This is a case of chi-square test. One group, proportion of one group against a reference is one proportion. Proportion of one group against another group is two proportion. More than two group is chi-square. Hope it is clear to all of you. We already studied p-value, right? And now you have a table which is showing all the tests. There are tests for averages indicated in blue color. Can you see the names here? There is test for proportion. You can see the names here. Similarly, there is also test for variance. What is variance? Square of standard deviation. Variance for two groups can be equal. That is known as F test. You are studying variance of more than two groups at a time. You have two options, Bartlett and then Levin. Whichever you want, you can go. You want to study the relationship, whether the relationship is linear or non-linear. No, if you are studying linearity, yes, it is correlation. If you are studying relationship in general, it is regression. So all of these are example of hypothesis testing. Clear now, all of you? So far, good? Any doubt?
No, sir.
Yeah. Suppose right now, if I conduct a small competition, a small activity, like I want all of you to take an A4 sheet and then, make a paper plane like this. Each one of you have to make 10 planes. Each one of you have to make 10 planes. And then after you make 10 planes, you have to fly every plane. And how much time it can fly in air? That is how I am going to measure the performance. All of you, do you understand? How many planes you are measuring? You are making 10 planes. And how do we measure the performance? The flying time of the plane. Now here, 1, 2, 3, 4, 5, 6 people are there. That means I have 6 groups or 6 samples. I want to find out who can make, the planes which can fly better. And whoever can make the plane, flying plane better, I want to send you for a national level competition. Do you understand now? Now, who is good among the 6 here? Who can do the job well? We don't know, right? Even you don't know. So we decided to do an experiment. What is that experiment? Each one of you will make 10 planes and you then throw it into the air and check how many seconds it is flying in the air. Now, each one of you, how many readings you will have?
10.
10 readings. Now, how can I compare your performance against others? By calculating average flying time. Flying time is a continuous data. So average can be calculated. Whose average is better, whomsoever average is better, he will be now considered for the national level performance. Now, what is this study known as? ANOVA. This is known as ANOVA because how many members are here?
6.
6. Any number, whenever number is more than 2, go for ANOVA. Suppose if I take only 2 of you and compare and conduct a study, that test will be known as
2 sample t-test.
2 sample t-test. Imagine I conduct a test, let's say Roshini and then Adip. 2 people, I'm testing. I realize Roshini's planes can fly better. So I'm sending Roshini. Now my decision can be correct, can be wrong also. Yes or no? I just tested with the 10 planes and concluded that Roshini can do better. But still there is risk is there in my decision. So, but that risk has to be limited. That is what we call it, level of significance, 5%, etc. So that's why, we are comparing the flying average for one person against flying average for another person. If the difference is too big, it is easy to decide. If the difference is too less, that's the time you need statistics. That's the time you need p-value and things like that. Whenever p-value is going below 5%, that means the difference is significant. Whenever p-value is more than 0.05, that means the difference is not significant. Whenever p-value is more than 0.05, it is better not to make any conclusion. If it is a very close call, that time you can see your p-value appearing more than 0.05. So such times, it is better not to make any conclusion. When I say flying time, we realize it can be ANOVA, it can be 2 sample t-test, it can be 1 sample t-test also. I will select people who can keep the plane flying for more than 60 seconds. 60 seconds is a reference value. Whoever can fly the plane for more than 60 seconds, you are considered for next level. Now, what is the hypothesis testing I'm doing? 1 sample t-test. I'm comparing sample average against reference. That is 1 sample t-test. Now, let me tell another scenario. Now, you each one of you make 10 planes. After that, whatever planes which can fly for more than 30 seconds, that is considered success. Whatever planes that fly less than 30 seconds, that is considered a failure. Now, I am talking in terms of success and failure and not flying time. Please note. Now, how many success each one of you get? Let's say Roshni gets, 6 planes success out of 10. Now, what is her proportion? 0.6. 6 by 10 is how much? 0.6. 60%. Now, Adip maintains 7 out of 10. 70%. Now, Gaurav maintains 8 out of 10. 80%. Now, I have to take a call. Who is good at, who is having a better proportion? It seems to be Gaurav because proportion is higher. But at the same time, I need to know the risk involved in my decision. During the study, Gaurav performed better. But tomorrow, in some other level, the same thing should get repeated. Yes or no? Suppose the next day, if I do the same experiment, suppose Adip is performing better than Gaurav, then my yesterday's decision was wrong. This is what we are quantifying before making decision. Whatever I observed, is it going to be a routine or that is going to be, just a one-time finding? If it is a one-time finding, you should ignore. But if that is going to be a kind of routine, then you need to take a decision on that. This is what we are checking with the p-value. P-value going below 0.05, yes, it is significant. When you are studying proportion, your test will be known as proportion test. When you are studying average, your test will be known as test of averages. In proportion test, it can be one proportion, it can be two proportion, or it can be chi-square test. If I say minimum, proportion has to be minimum 50% and above. Then each one of you is comparing your proportion, whether you are meeting and you are going above 50 or not. That is one proportion test. I compare one candidate's proportion against other candidate, that is two proportion test. When I compare all the proportions at a time, more than two, that will be known as chi-square test. That's it. This is what you have seen here. Can you understand now? Now tell me, what are the tests available? What are the tests available? Tell me, what are the name of the hypothesis testing you are introduced to now?
Single t-test, double t-test,
One sample T, then
sample t, sorry, sample t, then sample G test.
One proportion test, two
one
proportion.
sample T, one
G.
proportion test, then one sample G test. Isn't it? One sample G test. We also have two sample T test.
Yeah.
Only I am speaking. You are troubling my throat a lot.
Then
Only to give some rest in between, I frequently ask question. You all purposely keep quiet that time. Tell me. One sample
ANOVA.
G.
The ANOVA test.
Silence study. Okay. So ANOVA comes under average or proportion?
comes
Average.
under average.
Average.
ANOVA is a test of average. Can you tell me a scenario where you have to take a decision in a similar manner in your workplace? Have you ever come across? Have you ever compared 4 products or 3 products based on certain characteristics? Have you ever compared any suppliers, 3 suppliers, 3 vendors, or 3 different groups? Do you ever compare or not? You never
Yes, sir.
compare?
Yes, sir.
We
We
do.
compare samples, vendors.
These are all situations for hypothesis testing. Imagine you have a boy and a girl. I mean, you have, 2 kids, a boy and a girl. And you are comparing their, performance in the math subject. That is also hypothesis testing, yes or no? According to your understanding, your daughter seems to perform better in the mathematics, isn't it? So this is your understanding. This is your understanding. We don't know what will happen in the next class, isn't it? In the next exam. But as of now, so far, your observation is your daughter is performing better. So you expect the same thing to continue in the future also. Anyway, your decision comes with certain amount of risk. As long as the risk is less than 5%, take a decision. The moment you realize the risk is more than 5%, better ignore your data. This is the guideline. That's all. And if the guideline has to be defined beforehand. 5% is a guideline. Alpha has to be fixed. If alpha is 5%, that means we always check p-value against 0.05. If alpha is 10%, we always check p-value against 0.1. Now, can somebody tell me why some people are called as diabetic patients after studying their sugar level? What is the logic behind? Everybody will have some sugar level when tested. Am I right or not? We have a big population of human being across the world. What is the population size? And we are targeting only people above the age of 25. Am I right? Or 30. After 30 only, they test sugar level and so many things. So 30, above the age of 30, what is the population size? A big number?
Yes, sir.
Big number. We really cannot study each one of them. So what we do is we take some sample of 1,000 people from each country. Now you will have some 40,000, 50,000 people. With the 40,000, 50,000 people, after doing fasting blood sugar testing, if you done, will you be able to find an average? Yes or no? This is now considered population average. Now you have so much data. Will you be able to calculate standard deviation? Calculate? You can calculate, right?
Yes.
Now variation, quantum of variation is also known. Central value is also known. Now you can fix the limit whatever you like. You can go for a 95% limit. You can go for a 90% limit. You can go for 99% limit. It is now in your hand because we know normal distribution. See here. Normal distribution. Can you see here? Now, what is this distribution is representing? Sugar level of human being in the world. Particularly, our focus is people above the age of 30. Now, what is their average sugar level? Can somebody tell me approximate value? Any doctor here? No doctor?
108,
Any
107,
pharma specialist? Pharma industry? You might be knowing, isn't it?
107.
Okay, 107. So 107 is average. That means approximately 50% of the people in the world will have a sugar level above 107. Am I right? Remaining 50% will have sugar level below 107. Now you have an idea to group the population. Yes or no?
Yes.
You can draw the line wherever you want. Let me draw a line here. Now this line is accounting for 95% of the human being. So what is this region represents?
5%.
Only 5% of the human beings will have sugar level above this line. This line is marked as line of significance. Now tell me, what is the chance for a human being to have a sugar level of above 120? Fasting blood sugar level of above 120.
Less only.
Yeah. How much is the chance?
It is less only 5%.
5% chance is only there. That is the reason why whoever having a sugar level of 120 and above, see this region is p value. Please note, this region cannot be more than 5%. This is what we call it p value. Whenever p value is less than 0.05, we realize we are seeing our statistics in the zone of significance. This is zone of significance. This area is zone of significance. So whoever falls here, they are now called diabetic patients. 5% of the entire population becomes your customers for your medicine. If the sales is not sufficient, I will shift this line. If I shift this line, now what happened? Now more people will now become my customers. Yes or no? The guidelines are framed based on the understanding of the population. Please note, all of you. With respect to the population, where is our finding? If our finding is at the center, it's not significant. This is quite normal. Whatever happens here, these are all normal. But whatever happens away from the center, this cannot be considered normal. This is abnormal. Special case. So special cases, we decide. Now, do you understand, all of you? All right. So the 5% or 10% is decided beforehand. Before any study, it is decided. Right? And we simply check where is our statistics falling. Our statistics falling at the center or falling away from the center. If it is falling away from the center, slowly it might enter the zone of significance. The moment our statistics appears there, the probability for our statistics to reach that value or even higher value is less than 5% only. That is what we are checking, p-value less than 0.05 or not. Now, with that understanding, let us proceed with some case studies. Hope you all can see my slide. And now, first study. And don't read this problem in the same condition. Let me change this. So let us go here. Imagine a company is manufacturing cooking oil. In the cooking oil, fat content should be 15%. Fat content must be 15%. And you are a dietitian. You want to recommend this cooking oil to all your clients. So before recommending, you want to ensure whether the cooking oil is really having a fat content of 15%. Slightly plus or minus is okay, but it shouldn't be significantly higher or it shouldn't be significantly lower, because you believe that if it is significantly above higher than 15 or significantly lower than 15, you think that it is not good for the health in long term. So you want to study that. So you are okay with 5% level of significance, right? And so you have taken 13 samples. See here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 13 cooking oil bottle you randomly purchased. N equal to 13, you can see here. Now, what is the belief? Belief is the population average, the value that is printed in the cooking oil. How much it is printed? Cooking oil is 15%. But when you calculate fat contents separately in a laboratory, how much it is coming? Average fat content, 16.6. Now you have a doubt whether the 16.6 is significantly higher or it is okay to adjust. Any expert here about fat content? An increase of 1.6%, is it very significant? See, if it is an exam mark, scoring 1.6 mark extra, I don't see it, I don't consider that as a significant. Am I right? Because 1.6 mark is very, very small. But I cannot apply the same logic for fat content. Yes or no? Hemoglobin level, if it is, extra by 1.6 number, 1.6 value, it may be significant. I don't know. Medical world only know that. So whenever you are not sure whether the difference is significant or not, calculate a p-value. And that p-value will tell you. So now what I do is, I calculate some statistics here. Sample mean is 16.6. Standard deviation of the population. See, sometimes population standard deviation will be revealed to you. If that is revealed, you go for G test. If it is not revealed, you should go for T test. Now, in this case, it is revealed. And so sample standard deviation is also calculated. Now, I want you to write down the hypothesis. What is null? Fat content. Don't read it as a, what do you call? I'll just change it for you. Yeah. Not transaction type. This is fat content. Fat content is 15%. Right? So null hypothesis is written. And now what we do is we calculate G score. You see here formula H bar minus mu divided by sigma. Can you see sigma here? That sigma is nothing but population standard deviation. Sample standard deviation is yes. You need to understand. Now, in this case, sigma is known. So you get accurate value of G score. And now that G score calculated to be 2.2. Calculated to be 2.2. When I actually go to the G table at 95% confidence level, the maximum G score permissible is 1.645. What is the G score permissible? 1.645. But what is the value I got? 2.22. The calculated G score is found to be more than the tabulated G score. The same thing, whenever the calculated value is more than the, the tabulated value, the same time, your p-value will go below 5%. Either you go by this method. Nowadays, nobody is using this method because nowadays the softwares are available. Nobody use the normal distribution table. So what I also suggest is you use the software. See here, the software is giving you the G score, same G score. Can you see here, 2.22. The software is also giving you a p-value. P-value is how much? 0.013. Now my only question is 0.013. Is it less than 0.05 or not?
It is less than 0.0,
That
0.05.
means it is significantly higher. In this condition, don't believe the company's statement. They are told no fat content is 15%. But here we see a significantly higher value. Significantly higher value means it is not advisable. According to the data, it shouldn't, it's the fat content shouldn't have come to the level of 16.6, but it has come here. That's why our p-value is going down. Whenever p-value is going below 0.05, you please reject the null. You reject the null, and the practical decision is don't recommend that cooking oil bottle to your clients. Clear, all of you? Now I want to show you the same thing in Minitab. So let me, yeah. See, understanding the calculation and understanding this concept, definitely, you have to put some effort from your side. Then, definitely you will be able to better understand. But definitely the first time it might be little tough. Excel calculator. I've shared this Excel calculator with all of you, right? So I'm
Yes.
just opening this because it contains the same data. Let me see whether I can. This is fat content, huh? Cooking oil. Can you see cooking oil and transaction time? Can you see the same data? Why I wrote cooking oil and transaction time is, it is after all a data. Both are continuous, isn't it? Cooking oil, fat content also continuous, transaction time also continuous. See, please don't worry about the example. Please try to understand the data type. If you come across a similar data type, you apply the method. So I copied this. And now, can you see my Minitab screen now? Yes or no?
Yes, sir.
Yes, sir.
Okay. So I now paste it here. Now let me remove this fat content, that word. Sorry, transaction type. I remove that. So what is available here is fat content. And now let us go for a hypothesis testing. Yeah. What is the hypothesis testing we should go for? Company says null hypothesis. Null hypothesis. Symbol is H0. What is it? Company has printed that fat content is equal to 15%. Now what is alternate?
Greater than or less than 15%.
In this case, if you write more than 15%, it is right tiled. It is right tile. It is up to you. You want to go for a right tile, or you want to go for a left tile, or you want to keep it two tile. That is up to you, depending on the scenario, right? And let us assume, a higher value is sensitive now. So I'm going for a, what do you call, the right tile. Now, alpha, the level of significance. The level of significance, alpha is equal to 0.05. Now, what is the test we should perform in this case? The test is one sample, T test or G test. I'll go for G test because sigma is known. Am I right? Sigma is how much? Standard deviation, which is population standard deviation. How much it is given? 2.6. With all this information, you can go for one sample G test. Now it is very simple. Go to stat, basic stat. Can you see one sample G? Can you please read the description, one of you?
One sample Z. Determine whether the mean of a sample differs significantly from a specified value when the population standard deviation is known.
This is the exact scenario. We also understood the same manner, right? So I click that. And now Minitab is asking me whether you have the summary of the data or data in a column. We have data in a column. Now I click here. Where is that column? That column is C6. I click and select. Now known standard deviation. How much it is? 2.6. Now you are asking Minitab to perform the hypothesis test. What is the hypothesized mean? What is the company believes or everybody believes? 15%. Correct? And now go to the option. 95% confidence level. When I declare 95% here, that means how much is my level of significance? 5%. Now, what is the alternate hypothesis? You want to keep it right-tailed, or you want to keep it two-tailed, or you want to keep it left-tailed? Let me keep it right-tailed. See, accordingly, G-score will vary. Accordingly, G-score will vary. For two-tailed test, you remember, we used 1.645. For right-tailed test, it will be 1.96. I'll show all of this, in a graphical visual format also. But that is why p-value tool is created. In all the scenario, p-value, we always check whether it is less than 0.05 or not. You don't have to go through the pain of remembering all the G-score and other things. So I say, okay. I again give okay. Now the test is done. Can you see G-score 2.22? Can you see p-value less than 0.013? Now all that you need to do is to check whether your p-value is less than 0.05 or not. Here, since p-value is less than 0.05, please reject null hypothesis. This is the statistical decision. What is the practical conclusion? Or what is the practical decision? Practical decision is don't recommend this cooking oil to your clients. Why? Why? Because too much variation. Variation is too much. According to our understanding, the variation is too much to the extent that the average itself can be shifted outside, beyond the control, beyond the confidence limits, which cannot happen easily. Please understand. This is letting us know that the company's process is substandard. Do you understand? So that's why we rejected the null hypothesis, and which means we decided not to recommend the cooking oil. Okay, all of you, are you able to correlate the practical conclusion and the theoretical decision? Theoretical decision is reject null hypothesis. That means our common sense says this, under this scenario, it's not a good idea to recommend this product. Yes or no?
Yes, sir. Understood.
Very good. So now imagine the population standard deviation is not revealed. So the same scenario will become one sample
One sample t-test.
t-test. The description also confirms that. Determine whether the mean of a sample differs significantly from a specified value. So let me do this. Again, the same thing. Why this is, I should select this. Oh God, why this time the column is not showing? Cancel. Column 6 contains the data. Stat, basic stat, one sample T. Oh, it's there, sorry, fat content. Click select. This time you see, it is not asking standard deviation. But what is the hypothesis to mean? 15. Option. Same condition. I want to keep it right tile. Okay. And again, okay. Now this time it is calculating another statistics, which is known as T-score. Please note, T-score is 2.79. Every time you need to refer to a different distribution, which I don't want you to go through. Always keep your decision based on p-value. Easy. Whether it is G distribution, T distribution, or chi-square distribution, F distribution, so many distributions are there. You don't have to worry. Now, look, can you see that you are ending up with the same decision here also? But G test is more accurate. Now, I want to show you how this G score will generate and what the meaning of it visually. For that, see here, I'll show you some normal distribution table, graph, probability distribution, view probability. Okay. Now, normal distribution, I am selecting here. Look here, mean how much? 0. Can you see 0 here? This is a assumption. Please note. Real time, always there will be some value for the mean. But this is an ideal scenario. Mean is how much? 0. Standard deviation is how much? 1. Now go to the shaded area. Go to the shaded area and try to find out the area. Let me choose the first one or this one, right tail. I'm choosing the right tail. See, the right tail means the last 5% area I want to understand. What is the point which is dividing the last 5% of the population from the rest? That is my interest. So I keep probability here. How much probability I'm giving here? 0.05. Now I am giving okay. It will generate the curve for me. What is the number now coming? Do you remember I referred to the same number earlier, isn't it? This is for 95%. This is for 5% level of significance for a one-tailed test. Two-tailed means it will be 1.96. I told you. You remember? Let me show you that also. Graph, probability distribution, view probability. Okay. Everything is same. But this time it should be a two-tail. Two-tail means the third one. Can you see here? 5% will divide into 2.5 on the right side, 2.5 on the left side. I do that. All else remain same. Now you will see your G-score becoming plus or minus 1.96. Okay. Are you able to see 1.96? So depending on the, whether the study is one-tailed, two-tailed, right-tailed, left-tailed, and level of significance, different G-score you have to remember. But instead of remembering the G-score, always the red color area, the area of the red zone will be 5%. 2.5 on the right, 2.5 on the left. So total is how much? 5% for a two-tailed study. For one-tailed study, all the 5% is on the right side. That's why using p-value is very popular nowadays. Nobody is using nowadays the old method. Nobody is ready to do the calculation. Instead, they will use these kind of softwares, a type of artificial intelligence. It will do all the steps which you have to do. That is what we call it AI nowadays. Am I right? Chat GPT is doing everything for you. Whatever you are supposed to do, that software program is doing. That's AI. So this what do you call your Minitab is also a kind of AI only. All that you need to do, this will do, and then give the thing. Clear, all of you? Now question, please. Any question? Anybody would like to ask? Any question? Anybody want to ask? Very clear? Will you be able to apply? Right.
Yes,
Now
sir.
let me give a scenario. You have 3 vendors supplying some product. You want to understand, or you want to understand whether there is any difference among the vendors in terms of anything, in terms of the transaction time or in terms of the material quality. You want to understand the difference. So how many vendors I told you? 3. That means what is the test you will do? If there are 3 vendors, you want to study them. You want to find out whether any one is significantly better or significantly poor. That you want to understand. Now tell me which hypothesis testing you will perform. Let
Analysis
me.
of variance.
What is
Analysis of variance.
Yeah, analysis of variance, provided data type is continuous. If data type is discrete, the same thing will become the chi-square. Now I am showing you my Excel file. Now transaction time. Oh, not transaction time here. See here, lab chart. Let me take this one. Laboratory turnaround time. All of you, you know the meaning, right? Turnaround time. The time consumed to complete a particular, process. Now, how many labs are available here? Tell me. How many labs you have?
4.
And the data is turnaround time. Turnaround time is continuous data. Now, what is the hypothesis testing you should do now? I select this. Tell me what is the hypothesis testing I should do now?
Hmm?
What is the hypothesis testing I should do now?
ANOVA.
Why ANOVA? There are more than 2 groups. Turnaround time is a measurable characteristics, continuous data. And so I compare average transaction time. Now null hypothesis, you see here null hypothesis. What is written?
Turnaround time is equal or equal.
All the turnaround time are equal. But alternate hypothesis, unequal. Another way of saying unequal is at least one of the laboratories turnaround time is different. Maybe better or maybe on the negative side. And now we need to conduct the study. So I already copied the data. Let me take it to Minitab. Let me paste it here. Oh, what happened? I have to copy again, I believe. So lab 1, 2, 3, 4. Control C. I come here. Maybe this time I paste it here. Now it is pasted. Now your data type. What is your data type? The characteristics measured is, what is the characteristics we measure? Turnaround time. What kind of data type it is?
Continuous.
Continuous. So what is the statistics? Statistics used for decision making?
ANOVA.
No. Statistics. Read this statement carefully. You use the statistics average. Average turnaround time is used for decision making. So, recommended test. The recommended test is ANOVA. All right. Now, let's go for ANOVA. Stat ANOVA. It is one-way ANOVA. Only one characteristics, which is the type of laboratory. Lab 1, Lab 2, Lab 3, Lab 4. Only one factor we are studying. And the output variable or the response variable is turnaround time. One-way ANOVA. Now response are in one column. Do you see the response typed in one single column or typed in separate column? Tell me,
Separate.
how is the response available?
Separate.
So separate column you select. Now click here. What are the columns? C8, C9, C10, C11. And you select all of them. Now come to option. Confidence level 95%. And two-sided, right-tailed or left-tailed. Keep it two-sided. And can you see something here? Assume equal variance. For performing ANOVA, the requirement is variances must be equal. The 4 columns of data you have, the variance must be more or less equal. So give equal, or if you want to test the equality of variance, that is a separate hypothesis testing, which we can do. I'll show you how you give OK. Again, you give OK. Now ANOVA is performed. Look at the interval plot. The interval plot clearly confirms laboratory 3 consumes more time. Can you see that? And laboratory 4 consumes less time. If you really want to take a decision and reward one of the laboratory, you can reward laboratory 4. Am I right? If you want to penalize one of the laboratory, you can penalize laboratory 3. Your decision will definitely be correct. You are 95% confident with this decision. Can you see the confidence limits? Upper limit, lower limit. Upper limit, lower limit. The lower limit, no, these limits are not overlapping with any of this. But if you consider 1 and 2, the limits are overlapping. Can you see here? In this condition, you should not differentiate. But 3 and 4, you can confidently differentiate. This is called significance. If you are studying only 1 and 2, it is a case of 2 sample t-test. No significance. There is some difference in the average, but we don't consider that difference as a difference. Now, whatever is the decision you want to make using data, you can definitely decide using the data because there is significance. In this condition, definitely p-value will become below 0.05. You can see here. Let me show you the session window for you. You see here. ANOVA. Can you see here? What is the p-value? 0.000. It is not 0. It is closer to 0. Minitab has rounded it, right? It is closer to 0. But all that we need is, we want to know whether p-value is more than 0.05 or less than 0.05. What is the case here? Less than 0.05. So what should you do? You should reject the null. Reject the null means what? Use the experimental finding for practical decision making or conclusion. That is the suggestion. Always believe the experiments only when associated p-values less than 0.05. Otherwise, risk of seeing an observation due to a random chance will be higher. The risk of observing your data due to a random chance must be less than 5%. This is what we are testing with the p-value. So you can now, that means, reject the null. Reject the null means one of the lab is significantly, or one of the laboratory turnaround time is significantly different from others. You want to identify the higher one or you want to identify the lower one, depending on the requirement, you can identify, and your decision comes with 95% confidence. And now you go there, see the average transaction time. You see here, what is the average transaction time for laboratory 1? 178.36. For laboratory 2, close call. But laboratory 3 on the higher side. Laboratory 4 on the lower side. See, when values are far away, you really don't require any statistical tools. Isn't it? But when it is a close call, that's the time you need to use all of these tools and to see the p-value. And let me show the p-value. Yeah, p-value is here. P-value is everything is available. And now see here, all the ANOVA information is available. All that, Minitab is doing it for you, and you take a call. Clear? If you want to study only for laboratory 1 and 2, let me show it for you. If I want to study only for laboratory 1 and 2, what is the name of the test? Come on.
2 sample t-test.
2 sample t-test. Let me show you. Stat, basic stat, 2 sample t. Both sample in one column. No, both sample in one column. Sample 1, laboratory 1. Sample 2, laboratory 2. Option, confidence level, this, and alternate hypothesis, different. Keep it 2 tile. Here also you have to assume equal variance. Put a tick mark. Now you give OK. Again you give OK. Now 2 sample t-test is done. Look at the p-value. Less than 0.05 or more than 0.05?
Greater than 0.05.
So what is your conclusion now?
It can be
Don't reject the
do
null.
not
Fail to reject null. That means what is the practical conclusion? Tell me, what is the practical conclusion? There is no difference.
difference between.
There is no difference in the turnaround time. But mathematically, there can be a difference. You see, lab 1 and 2. Which lab is maintaining a lower transaction time or lower turnaround time? 1 or 2?
One.
But
One.
still, statistics is suggesting you not to support 1. 1 and 2 are almost same. So there is no significant difference. There is difference, but there is no significant difference. Hereafter, if you make a statement, please use the word significant only when p-value is less than 0.05. Otherwise, you only say there is a mathematical difference, but no statistical difference or no significant difference. There is a difference, in saying that significant difference. When I say significant difference, that means it is statistically significant. When I say difference, any difference is a difference, but significant difference is difference with a p-value of lesser than 0.05. Clear all of you so far? Now test of averages in any product, any company, any scenario. The moment you understand your response variable is a continuous variable. And if you need to understand the number of groups you are studying. Accordingly, you can pick up the hypothesis testing and then you can conduct it and take a decision. All right, so this completes